Hello students, in today's session of NCERT chapter 9, Mechanical Properties of Liquids, very basics on Bernoulli's equation will be cleared through illustrations. In another session, we have gone through topic is pressure and another topic is Archimedes principle and laws of flow. Basics are cleared through illustrations which you can review on sethiswiftlearn. In today's session, we are going to discuss the principle of Bernoulli's theorem. What is velocity of a flux? What is venturimeter? Etc. etc. The points which are going to be discussed are being very useful and important for entrance examiners also. Please go through the session completely. Now let's study the concept and questions. Now let us discuss regarding the hydrodynamics. What is hydrodynamics? Fluids in motion called fluid dynamics or hydrodynamics, whereas fluid at rest is known as hydrostatics. A streamline flow, type of flow में streamline flow of a liquid is that flow in which each particle of the liquid passing through a point travels along the same path and with the same velocity as the preceding particle passing through the same point. That is known as a streamline flow. It is also defined as a curve whose tangent at any point is in the direction of fluid velocity at that point. This is shown in the figure. This is the tangent, this is the tangent, this is the direction of velocity of the fluid. Properties of streamline flow. In a streamline flow, no two streamlines can cross each other. If they do so, the particles of liquid at the point of intersection will have two different directions of their flow, which will destroy the steady nature of the liquid flow. This is one of the properties. Second, the greater is the crowding of streamline at a place, greater is the velocity of liquid particles at that place and vice versa. Right? Next. Equation of quantity. Equation of quantity gives the rate of flow of liquid. Rate of flow of liquid is same at different sections. It states that during the streamline flow of the non-viscous incompressible fluid, that is known as ideal fluid, through a pipe of varying cross section, the product of area of cross section and the normal fluid viscosity, A into V, normal fluid velocity remains constant throughout the flow. That is A1 V1 equal to A2 V2, that is rate of flow of liquid. Rate of flow of liquid. Laminar flow is the flow if the liquid flows over a frictionless horizontal surface in the form of layers of different velocities, then the flow is called laminar flow. In laminar flow, particles of one layer do not enter into the another layer. In general, laminar flow is a streamline flow. What is turbulent flow? In rivers and canals, where the speed of the water is quite high or the boundary surface causes abrupt changes in the velocity of the flow, then the flow becomes irregular. Such a flow is known as a turbulent flow. Right? Bernoulli's theorem. What is Bernoulli's theorem? Bernoulli's theorem principle is based on the law of conservation of energy and applied to ideal fluids. Ideal fluids कौन से होते हैं? Incompressible, non-viscous. It states that sum of pressure energy per unit volume, kinetic energy per unit volume, and potential energy per unit volume. Sum of all these is known as Bernoulli's theorem, right? Of compressible, non-viscous fluid in streamlined rotational flow remains constant at every cross section throughout the liquid flow. So, what is the condition for ideal fluids? Of an incompressible, it should be incompressible, non-viscous, streamlined flow, irrotational flow remains constant at every cross section throughout the liquid flow. Right? Now, point to be noted that while applying the conservation energy principle, then we have assumed there is no loss of energy due to friction. While deriving the Bernoulli's equation, we have assumed that there is no loss of energy due to, but actually there is certain loss. But in fact, when fluid flow, some of the energy lost due to friction. Generally, when the fluid flows in different layers with different velocities, These layers exert friction forces. This property is called viscosity. Means when we derive the expression, we have assumed ideally there is no loss of energy. Now, let's discuss certain formulas. Now, certain formulas and application of Bernoulli's theorem. First is speed of a flux. That is Torricelli's law. The velocity with which the liquid flows out of an orifice. What is orifice? Orifice is a narrow hole. This is narrow hole of area of cross section A is equal to that which a freely falling body would acquire in falling through a vertical distance equal to the depth of the orifice below the free surface of the liquid. Means velocity of flux is twice GH under root. This is H. This is depth of orifice. Depth of orifice. This distance is another. When range is given by twice under root H, H minus H. That is twice under root geometric mean. That is twice geometric mean of height and depth. Height and depth. This is one, this is this one. Geometric mean of this distance and this distance is the range. And range R will be R maximum if H equal to H by 2. On simplification, R maximum comes out to be twice H. R maximum comes out to be twice H. Time taken to empty the tank, that is equal to A by A under root twice H by G. A is area of cross section of tank and A is a small area of orifice, area of orifice, area of orifice. This is regarding the Torricelli's law. Venturimeter. What is the purpose of venturimeter? It is used to measure the flow speed of non-uniform cross section pipe. This is non-uniform. Then it is given by V1 will be equal to twice GH over under root A1 over A2 whole square minus 1. This is the velocity. This is given by this. A1 is the area of cross section. This one. A2 is the area of cross section. This height is the difference between the liquids. That is height H. Now, according to continuity equation, A1 V1 equal to A2 V2. That is equal to rate of flow liquid. According to requirement of question, you can find anything. Right? Now, let's start with the question. Question is, water is flowing through a horizontal tube of non-uniform cross-section area. Non-uniform cross-section. At a place, the radius of tube is 1 centimeter, where velocity is 2 meters per second. What will be the velocity of water where the radius of pipe is 2 centimeter? Means like this. R1 1.0 centimeter, velocity 2 meters per second. R2 2 centimeter. P2 find out. Concept applicable is quantity equation. That is rate of flow of liquid, that is dV by dt, that is equal to A1 V1 equal to A2 P2. Rate of flow liquid at this point and rate of flow liquid at this point will be same, right? In that case, A1 pi R1 square into V1 equal to A2 pi R2 square V2. Therefore, V2 comes out to be pi goes R1 over R2 whole square into V1. This comes out to be R1 1.0 2.0 into V1 2. That is 1 by 4 into 2. That comes out to be 0.5 meter per second. Means velocity of water where radius is here, the velocity will be 0.5 meter per second. Right? Now question. Question is calculate the rate of flow of glycerine of density 1.25 into 10 to the power 3 kg per meter cube through the conical section of a pipe if the radius of its ends are 0.1 meter and 0.004 meter and pressure difference across length is 10 Newton per meter square. We have to find the rate of flow of glycerine. Concept applicable. To find rate of flow, use continuity equation. Use continuity equation. That is equal to A1, V1 equal to A2, A1, V1 equal to A2, V2. Right? According to also and Bernoulli's knowledge equation to find the velocity. According to Bernoulli equation, pressure energy P, pressure energy per unit volume, half rho V square plus rho GH equal to constant. Equal to constant. We have to use these two concepts. Right? Now, according to question, density of liquid is given to density. Area is pi R1 square A. This is R1 is 0.1 meter. R1 is 0.1 meter. R2 is 0.004 meter. 0.004 meter. V1, let V1 is at this larger area, V2 is this. If V2 is greater than V1, then area decrease होगा, pressure increase करेगा, right? Then, first of all, using continuity equation. Area is known, we have to find either V1 or we have to find V2. A1 V1 equal to A2 V2. In this case, we will solve two equations in V1 V2 and solve them, find the answer either V1 or V2. A1 over V1 over V2 equal to A2 over A1. That is pi R2 square upon pi R1 square. On simplification, pi goes, R2 is 0.004 divided by 0.1. 0.004 into 0.1 whole square. On simplification, this comes out to be 3 in 1, 4 upon 100. That is 1 by 25. V1 over V2 comes out to be this one. Right? And also using equation, Bernoulli equation, sum of three energies per unit volume here will be P1 plus half rho V1, P1 rho half rho V1 square equal to P2 plus half rho V2 square, H equal to constant. H equal to constant that we'll consider. Then half rho velocity will be higher at this point because area is smaller. So V2 square minus V1 square, that is equal to rho 1 minus rho 2. Therefore, V2 square minus V1 square equal to twice P1 minus P2 divided by rho. Substituting values, pressure difference is given to 10 Newton per meter square. This is P1, P2. This is P1, P2, P1 minus P2. 10 twice into 10 divided by rho. Rho is 1.25 into 10 raised to over 3. From this V2 square minus V1 square comes out to be, on simplification, this comes out to be 1.6 into 10 to the power minus 2. This is V square, the meter square per second square. This is equation 2. On solving equation 1 and 2, we get V2 equal to 1.3 meter per second. Therefore, rate of flow of liquid, we can use A1 V1 or we can use A2 V2. We are using this case. So pi r 0.004 whole square into 1.3 meter. On simplification, this comes out to be 6.43 into 10 to the power minus 4 meter cube per second. I have leave the calculation for you. All concepts has been cleared. What was the requirement? To find the calculate the rate of flow of glycerine. Glycerine is entering here and existing here. So we can find A1 V1 or we can find A2 V2. First we find the relation between V1 V2 and another equation find V1 V2 by using Bernoulli's equation, keeping H equal to constant. Right? Next question. Before start of the next question, I will request that these concept killing videos, which are very useful for 11th standard, 12th standard, CBSE board, state boards, JEE, NEET, CUET and other entrance examinations, which you can review on sethiswiftlearn. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, please subscribe it and share with your colleagues and friends. Now let's start with the question. Question is, water is flowing smoothly through a closed pipe system. At one point of the speed of water is 3 meter per second. While at another point 1.0 meter higher, the speed is 4 meter per second. Two parts are in this question. First part is, if the pressure is 20 kilopascal at the lower point, what is the pressure at the upper point? No, let's start. One is lower point, one is upper point. V1 is 3 meter per second. Upper point V2 is meter per second. H1 0 reference line, H2 1 meter higher, so 1 meter. If the pressure at the lower point P1 20 to 10 to the power 3 Pascal, that is a SI unit. P2 we have to determine. Water is flowing. Density of water If it is mentioned that time, otherwise you have to consider 10 to the power 3 kg per meter cube. Now, applying according to Bernoulli equation. According to Bernoulli equation, P1 plus half rho P1 square plus rho G H1 equal to P2 plus half rho V2 square plus rho G H2. Right? Now simply substituting the values. Substituting values. P1 is 20 into 10 to the power 3 plus half into 10 to the power 3 into 3 whole square plus 0. Actually, we have taken 1 meter higher is other side of 0. P2 we have to find out plus half into 10 to the power 3 into V2 4 plus rho 10 to the power 3 into 10 into x2 1 meter area. On simplification, we get P2 equal to, P2 comes out to be 6.5 kilopascal. This is the answer. Alright. Now we have to go for second part. In second part, if water stops flowing, water stops flowing. If water stops flowing, that is V1 equal to 0, V2 equal to 0. Then in that case, P1 plus rho GH1 equal to P2 plus rho GH2. We have to find in this case is substituting values. Values put करने के लिए P1 is 20 kilopascal, 20 into 10 to the power 3 plus 0 equal to P2, we have to find it out, plus rho plus 1 H 10 to the power 3 into 10. On simplification, we get P2 comes out to be 8 kilopascal. 8 kilopascal, that is 8 into 10 to the power 3 Newton per meter square. That is the answer, right? Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.